Hello ladies and gentlemen, my name is Decryption and I hope you are well. So you may have seen it in many different games when you see people glitch it or they fall through the ground and they manage to keep falling. Very few games just allow you to just keep falling infinitely. There normally is a safety net there just to catch you. So say me here, if I manage to swim all the way over here, past all the mountains that are invisible and drop down here, what would happen? Well, in the game, you'll just keep falling forever and ever and ever until eventually you crash the game because you've run out of a coordinate vector. It overflows the float or something like that. However, you'll notice in most games like Dishonored, GTA, stuff like that, there's a respawn procedure where you'll fall for a while, but then you'll eventually hit something and bang. You'll appear bang, back just somewhere back on land, just like that. In today's tutorial, we're going to add this simple yet really nice effect into the game. So let's get started. So as per everything normal, I have set up a demo map just to make this easier to test so we can drop down really easily. And I've just called it M Falling Respawn. All it has is my custom game mode and just some very basic stuff, like a plane. I can click play and I can do whatever I need to. More importantly, I can run and jump off the edge, which is exactly what we need. So there's multiple ways of approaching this to however you want it to work in your game, and that's the key part you need to think about. So games that are linear in enclosed spaces, you're going to be far better setting up spawn points where the player can spawn next to if they're in a specific region. That's one way we're going to look at it today. The other way is for more open worlds like Grand Theft Auto, where you have a large open world. You can't put spawn points around different areas. You'll be going forever. So the next part, which we'll look at for open world versions, is we'll fire a line trace down and we'll find the nearest point where it's walkable by an NPC, and in theory, if it's walkable by an NPC, the player should be safe to be on there as well. So I'm actually going to split my map into two, and I'm just going to add just a big cube in the middle, like so. And then this side of the map will be our linear cave, So we've got a tightly packed cave, if you imagine something like Tomb Raider or Dishonored, where you're in a house, or even in GTA if you are inside a building, kind of thing like that. And we're going to have set points that if you fall through, we will shoot back up, find the nearest acceptable point and go to that one. And then the second half will be your open world, we'll fire a line trace and find the best place to be. So all of this is good, but you could just override this and just immediately kill the player. That's something else you can do. And for that, you could easily just add a pain-causing volume. And if you set your damage up with Unreal using their default health system, you could just add this, set the details to be something really high, so the damage per second is something like, 10,000. Pour it all the way down. As your character falls, it will hit it, they'll die. That's one easy way you can do it. But let's jump straight in and start looking at the spawning aspect of it. So I've just gone and copied this cube system over here from my Running Race series, and that's going to act as our linear map. But to make it so we can actually fall, what I'm going to do is just basically move this path all the way across like so, and then duplicate it and we can just shrink it down and do whatever we need. Remember, this is more of a safety net. Not many games are actually built on this being a function. It's more so to make the game stop crashing or doing anything dodgy if the player so happens to find a glitch. That's what it's mainly for. So you can see now if I start the game, in my gaming eyes, I'm coming down here, I'm trying to speedrun it. I know there's a glitch here that if I run over here, I can jump across to here, and then I can get out of bounds of the level like so. So we need to capture when the player's fallen down there, and then in this linear case, we want to find the nearest point that they can go to that's acceptable and put them there instead. So what I'm going to do is come to my blueprints folder, and inside my MISC, I'm going to go into my triggers folder, and I'm just going to create a new folder here called Falling Triggers. And inside here, I'll just create a new blueprint class, and I'll set it to a type of box trigger, or trigger box, and I'll click select. I'll call this TB for trigger box blueprint, so BP, and I'll call it falling trigger, and I'll open it up. So the reason we use trigger box as a default base is it just gives us everything we need built into it, like so. So I can come into the collision component, which is our trigger box, and I can just set it to something a bit larger, so we'll do 100 by 100. Because we're falling on the Z-axis, I'm actually going to make the Z quite large at, say, 5. And that means when I drag it in, it looks like it's quite chunky. But if you imagine you're falling and falling and falling, we don't want the player to skip it because they're, if they're running at 30 frames per second, if you speed up, you may jump over it. We don't want that. So I'm just going to add that just below. You can decide how low you want it. So I'll just set it about there. But one thing you want is you want it to be bigger than the area you're looking at. So I'm going to set mine to 200. So here, there is absolutely no feasible way that the player can drop out of here like so. In the open world map, we'll set that huge, absolutely massive. But for this linear one, even if the player managed to do a jump skip and they managed to fly all the way over here, chances are they're still going to fall out and hit it there, which is perfect. So let's now adapt this so it will work with both methods, depending on what variables we give. I'm going to come back into my variables here, and I'm just going to create a new variable called respawn points, and I'll just set it to a type of target point. A target point is simply something built into Unreal that literally just gives you an arrow. It's just an actor, like so, that you can recall and just use for anything you want, but unlike a normal actor, it's not visible in the game, and you can just see it in the editor, making it a bit easier. So I'm going to come and right-click this to turn it into an array, because we want multiple of them. And I'll hit compile and save. I'll then come back to my map, and then I'll start placing these target points, just random ones, just around my little map here, where I want the player to respawn if they fall. So I'll just place one right at the beginning, so if they somehow manage to fall there. I'll place one at a safety land here, another one over here, and another one over here, like so. Just dead basic like that. I'm even going to parent it to the falling trigger, just to keep it, nice and neat. Now what this means is as we fall down here, if we trigger this, we can search all of these for whichever one's closest to us, and then respawn the player there. So, back on my falling trigger blueprint, I'll select our collision, scroll down, and I'll do on component begin overlap. I'll double check that it's the player, so I'll say equals, and I'll just check if it equals the get player pawn. And remember, if you're on a multiplayer game, you're going to want to check if it's the player a different way. Another option is you can add a custom collision profile to this, so it only checks for your player and anything that's associated with the player. I don't mind it being this way because I want to do something if it's an NPC or something. So if it's not the player, then it means it's an NPC of some kind. I'm just going to drag from the false and add a print text. I'll drag backwards and just do a format node. And I will say curly brace, name, close curly brace, just hit the false trigger. And I can connect the name to the other actor. And from the other actor, I can drag down and do get display name. And I can plug that into the name like so. So what that will do is print out something else has just hit the fall trigger. And then I can get the other actor one more time. And I can just call destroy actor like so. And that just means it'll clear up anything else that's falling on it, excluding the player. However, if it is the player, this is where we want to check what do we need to do. So if it's got some respawn points, so we can drag off this and do is empty. So if it's not got any respawn points, then it means we want to do the line trace route. We're in an open world potentially, we've not added any. So we'll fire a line trace far above from the player, fire down, find the nearest point. However, we're working on respawn points at the moment. So if it's false, we want to find the nearest respawn point to the player. So what I'm going to do is come and create a new function called find nearest respawn point. Then I will right click and do get player pawn. Remember, if you're on a multiplayer game, just pass in your other actor to it and use that instead. I'm doing a single player game, so it's fine. I can do get location, get actor location. I'm going to promote this to a local variable called player's current location, which means we don't have to keep getting the current location every time. We've just got it once nice and easily. Then I can drag the respawn points in. I can for each loop over them all. Then from the array element, I can get the actor location. I can drag off this and do distance. Vector is the one you want. And then I can plug in the player's location. So this is going to give us the distance between the target point and the player. So we're looking for the shortest version. So what I'm going to say is this less than? And then we now need a value of our current distance. So I'll drag this down and just do promote to local variable, current respawn point distance, and I'll add a branch afterwards. Now, the keen-eyed of you might actually see and say that the current respawn distance by default is 0, which means, is anything ever going to be less than 0's distance away? No, that's not going to happen. So what I'm going to do is just come and set this to something insanely large, like 99,999, something insanely large, just because then if the player is out of bounds of all of that, on completed, if we don't have a target point, we'll just pick a random one, just to assume the player is really, really far away somehow. So remember to set the distance on there, otherwise it won't work. Then, if it's less than it, then we can come and set the current respawn distance to the distance that we've just calculated. And then we can come and promote that current array element. So we'll do promote to local variable called chosen respawn point. And we'll just add it over here. We'll do a bit of cleanup, promoting this array element to a local variable called current respawn point. So the current is the one we're looking at. Chosen is the one that we're most likely going to go with. So I'll just tidy this up a little bit like so. And because we've promoted it to a variable, it means we no longer need this blue line all the way over here. We can simply say set the chosen one to the... Looks a lot neater already. So this will come through and loop through all our respawn points, check the distance from the player. The shortest one will have its distance stored, and then it will be set as the chosen one until it gets to the very end. If it's false, we're not going to do anything because it's far away from the player. And then on completed, we're going to check if we have a chosen point. So I'll drag it in, I'll right click and choose convert to validated get. This means we can just do a nice little thing here without having to do an isValid node. If it's invalid, then it means we've not found a chosen point. They're all either really far away or something's glitched out somewhere. So in that case, all I will do is get the respawn points. I will simply get the first one, and then we're just going to use that. That's it. So I'm going to right click and just do return node, and it'll add a return node. I'll connect this to the is not valid, and I'll connect the get to it to output which node we want to use. So we'll do selected respawn point, and then we'll duplicate this return node on the is valid and just say here's the chosen respawn point, like just to make this function a bit nicer. So now back in our event graph, we can drag the find nearest respawn point. We can connect this to the false because it's not empty. And we now have our selected respawn point like so. So to make this easier, because we're going to be respawning the player in both ways, I'm actually just going to come and create an event down here. So I'll do add custom event called respawn player. I will add an input, which will be the location to spawn the player. So we'll do a vector. You could also do rotation if you want. I'm not going to bother with that one because if we're doing the line trace, you're not really going to have a rotation anyway. So from here, I will just do get player pawn. And remember, if you're doing a multiplayer one, you can just get the other actor or promote it to a variable or pass it into this function directly, either way. And I'll just do set world location, actor location. I'll set them to the location here. And we'll leave it like that for now. We may have to go into disabling ragdoll and such, but we'll get into that one. But now we can come up to here and we can simply call respawn player, passing in the new location from the selected. Then before we try it, we just need to come and select our falling trigger and make sure that we add all the respawn points that are connected. So there's two ways we can go about adding all of the target points. If you've got hundreds, if you've got a big linear level, it might actually be better to come into the falling trigger. On event begin play, we will do get attached actors, and we'll do recursively. We'll loop over all of these actors, and we'll just say cast to a target point. And because target points are always in memory anyway, because it's an Unreal Core thing, the casting will be okay. And then we'll just say add it to the respawn point. So we can do add, and we can connect it. And that means as soon as we click play, we don't have to assign all of them manually. It will just automatically do it. So if I click play this time, you will see I'm speedrunning the game. I found a cheat that I want to pursue, so I'm going to come down here. I'll fall down, it will go, and then you'll see it will fly us away apparently. That's new. So this could be down to a number of things. It could be due to ALS, it could be down to the velocity. So let's put some fixes in that should work for the majority of people. So the first thing I'm going to do is on my respawn player, now that we've got the pawn. So in order to stop the characters from their velocity from proceeding, I'm just going to come and get player character. And we specifically want the character, not the pawn. It gives us some more options. I'll drag off of this and do get component by class. And we want the character movement component. If you're using the new mover component, you'll need to find how to stop the velocity on that. But for the old movement component, we just do set velocity. I'll set it to 0, 0, 0, so they're not being forced in any current direction. I'll also drag off the component, and I'll do set movement mode, and I'll just set them back to walking, just in case they're set to ragdoll or anything funky. And then finally, just to stop any attempt at the physics from running, I'm just going to drag off and do launch character. This is why we want the character. And I'll just set the velocity to 0, 0, 0 on everything. Then I'll connect the location back up like so. And in theory, we should now have stopped the character from being forced in any direction. So if we try it again, and run this time, you'll see we instantly respawn just at the nearest point. If we dive over here, you see we respawn here. How cool is that, ladies and gentlemen? Which means we can now get out of bounds from any way here. So if I speed run, I've found a little cheat this way, we'll dive down here, or I've fallen out of bounds, it goes boom, get back here. How cool is that, ladies and gentlemen? Okay, so the next way is when we've got a big open world like this. So if you imagine you've got a big open world here, we don't want to be adding trigger points throughout the entire map. It'd be insane, and it's too hard to really justify. So what we're going to do instead is when we fall down, we're going to shoot back up to the end. We're going to fire a line cast straight down. We're going to get it to hit some point on the map where we're under it. And we're going to find the nearest point where it is walkable by an NPC. Because if it's walkable by the NPC, then the player should be safe to spawn there. And then we're going to spawn the player just like we did over here, but there instead. To make this work, I'm going to add a nav mesh bounds volume into the map here. And we'll stretch this out. If you've never used a nav mesh bounds before, it literally just lets your NPCs walk on it. That's it. But if I press P, you'll see it's highlighted in green because this is where the NPCs can walk, and outside of this is where the NPCs can't. So just to make a little gap here, what I'm going to do is just shrink this all the way down and just basically make a gap in the middle of it, somewhere where we can fall in, like so. So now we've got a space where we can fall in. If I press P, it's clearly not part of it, which is good. When we hit a different trigger down here saying you need to spawn from the above, then we can come up, fire our big line trace, or we'll probably do a box trace or a sphere trace, find the nearest point and go from there. So I am just going to make sure that this one over here is not conflicting. Normally you'd have these on different maps or something. So for now, I'll just come and grab the scale of it, set it to something like 20, just so it's not interfering with it. It should all still work. But then over here, we can add our new trigger box. So I'll just come back and add our trigger box under it. I'll drag it down a bunch and just make sure it's not conflicting with the other one. Just enough so that if we hit it, we can fall for a while and then we, respawn. And then back in our falling trigger, On our overlap, we check if it's the player. If they've got respawn points, then we go to the nearest respawn point. However, this one doesn't have any respawn points, which is good. So it means we come up here. So we can do our sphere trace on true. So I'll add a new function, trace for land, and we'll drag off of this and do sphere trace by channel. That one will work fine. The start location will be our player's current location. So just like we did on the finding the nearest point, I'm going to get the player pawn, their location, get their act location, and promote it to a variable. I'll just come and paste this inside the trace for land here because we want to do the same thing. You'll notice that the node is grey, but that's totally okay. Right click, create local variable. So for the start point, I'm going to right click and choose split, like so. I'll get the current location and just do break. I'll plug the X and Y in, so they're correct. But the Z, I'm actually just going to manually come and do something like 10,000. Something that I know is really, really high above all of my map. So you can see at the moment, this plane here is 0. 10,000 will be all the way up there, far above it. If you've got mountains and stuff, do it higher than that. Basically look for a really high point. So I'm just going to set mine to 20,000, just in case I have mountains later. The end point, we will just connect the player's location to, like so. So it's firing from the very high up in the sky, above the player, and firing straight down at the player. And then just to make sure we're not going to hit this little gap here, because we want to make sure we get either side of it, I'm going to come and set the radius to something large, like 1,000. So if we come and add a sphere in, and set the radius, let's just play with the scale, 1,000 might be a bit big. So if we do 100, see 100's still massive. So we could try 10. Now I know they're not identical, but it is a good one to do. So we'll do about 20 and we'll try that. The trace channel will just keep to visibility. So if we can see it, we can collide with it. The actors to ignore, I'll just make an array from it. And I'm actually just going to plug the player pawn into it, just so it ignores the player if we accidentally hit them. We'll draw a debug for duration of 5 seconds, just for now, just so we can test it. So let's go and see what this does now. So back on our event graph, we'll drag in our trace for land, just put it there. We'll hit compile and save. Now let's fall off and see if we actually hit it. So I'm going to jump relatively close to it. If I fall off now, I'll press F8. You'll see that it has indeed fired a trace down. As expected, 5 is a bit small, but you can see from where the player is or wherever he's moved to, it's managed to fire a trace and say we'll be happy to spawn there, which is a good point already. So I'll come in back into our trace for land and we'll set the radius to something like 1,000. I think I was right with that one. We'll right click, play from here. If we drop down now, press F8, you will see eventually, boom. That's where it wants us to spawn, or at least it's found it. If we drop in the middle of it roughly without much moving, we'll be able to get it to almost hit in the middle, but you can see it's still found a collision point where we can land. So now that we have our sphere point, how do we tell if we can actually navigate that on our navigation here? Because you'll see there is actually a gap where it can be. And if not, how do we find an area that's close to it? For example, if we fall off over here, it will land here. That's not navigatable. How do we tell it to go over there? So it's actually really easy with a node that's been in Unreal for ages. So we're just going to simply use the project point to navigation. And this is one that's built in, and it basically lets you specify a point and then tell it how large of an area you want to be to get to that. And it should give you the closest location it can. It might be the exact location. So before we use that, let's just add a branch and make sure we've actually hit anything. If we haven't, then it means we're potentially hitting something far out of here. You know, the player's managed to completely do it all the way over here. So depending how you want to handle really obscure ones like that, you could either recall this function with a much larger radius and keep increasing it until you find a space, or in my case, I'm just going to add a print statement saying player got out of bounds badly. and then I'll probably end up killing them, dealing damage, something like that. So if we're true, it means we have successfully hit something. So let's break on this. Just move this under here. The break results, we can now use our project point to navigation. So our point is our impact point. So where we've hit the nav mesh. The query extent is how big of an area we want to look for it. So I'm going to set this to something fairly large. So we'll just do 100 by 100 by 100, which means it will set 100 by 100 Unreal units to look for an area that it can go to. So here, it should easily find this area over here. So we'll add another branch to this, just to make sure that it has actually found somewhere it can get to. If it hasn't, then again, I'm just going to print out and probably kill the player or something because they've got really, really far out. But if they have, then we can successfully return the projected location, which should tell us where to respawn the player. So if I come back to the event graph, we can now add our respawn player up here and connect it like so. So if I click play this time, play from here, you can see when I jump down, it should now fire a trace and respawn us in a nice place. How cool is that? So I can run, do a big leap over here, I've missed the area, but boom, the line trace says this is where you need to go. We can test if this is working. As you know, there is a gap there that we can't spawn down. So in theory, if I slowly walk off, it will fire a line trace and hit that gap. But because it's not navigatable, it will move us to an area that is just navigatable. How cool is that, ladies and gentlemen? So the system is really, really basic, but it's one of those that can save your game. So like I say, I'm not saying it's a miracle cure for everything. So like if I extend this all the way out, a bunch of copies of this with no nav mesh, if I duplicate here, far, far away from anything navigatable. So if I do it over here, far away from anything that's navigatable, if I fall down, I'm assuming it should show us the error message. Player got out of bounds badly, yeah. So that's you flew so far beyond the map, you've glitched it out, we don't know what to do. But chances are you probably won't ever get that far. If you do, just keep expanding your game. But if I come and duplicate this, you can see I've got plenty of nav mesh radius now. If I come over this time, you'll see when I drop down, it should query it radius nicely and put us somewhere nice here. You could even expand it and say even if it doesn't find a sphere point to trace the player to, we could technically still make it project itself. So instead of player got out of bounds here, what we could instead do is select off of this point here. So we'll drag backwards and do select vector. And we'll say return value into there instead of the branch. And we'll say no matter whether it hits or not, if it's true, A, because it's found one, use the player's location to trace from. Otherwise, we can just get the player's current location and try to find anything that can trace to that instead. And I've set it to 10,000 just so we've got a nice radius. And that way, the only way the player can get out of radius now is if they're really, really out of bounds, to the point where they're 10,000 units out of bounds. And what this means now is even if I jump over here, so the sphere trace cannot make a find, it will still put us at a navigatable area, even though this trigger's not here, because it's tried to find us using the nav mesh. How cool is that, ladies and gentlemen? It's such a simple concept, but it can really add to your game just as a safety net. That's really it. So we've done two types. We've done the specific pointed ones in here, which works great for when you're inside in caves or something like that. Because if you imagine the sphere trace will come and hit the roof, you don't want to be teleported to the roof of the cave. But we've also done the large landmass. So I recommend using both. It's really, really helpful. So you can see I've got the big one down here. It's a single blueprint, and it all determines whether you put respawn points in it or not. So thank you for watching, ladies and gentlemen. I hope this was helpful. If you've got any other tutorials you'd like to see, please let me know, because our game is expanding and we've got some really cool stuff on the horizon coming soon. Thank you for watching. My name is Decryption, and I will see you next time.